Hi, good day everyone. Today, our group will be reporting about transportation engineering. By the way, I'm Lorraine Custodio and I'll be giving you a brief definition about transportation engineering. But before we further discuss it, let us first define what civil engineering is. So, civil engineering is a profession that deals with the designing and executing of structural works that serves the general public. Examples are dams, bridges, canals, highways, and sewerage systems. So, in short, mostly everything that we see around us is all about civil engineering. So, civil engineering has branches or subdisciplines, and transportation engineering is one of it. So let us now further discuss about transportation engineering. Transportation engineering is a branch of civil engineering that is involved in the planning, design, operation, and maintenance of safe and efficient transportation systems. These systems include roadways, railways, and waterways. Transportation engineering is also concerned with moving people and goods efficiently, safely, and in a manner conducive to a vibrant community. The importance of a transportation in a country is comparable to the veins in the human body. Veins help the health of the human, and similarly, the transportation keeps the health of a nation in good condition. Transportation also plays an important role in the economic, social, and commercial development of the country. And in order to properly execute things in the field of transportation engineering, we do need an expert, and it is called a transportation engineer. There are a lot of roles and responsibilities of a transportation engineer, but let me give you some of it. So first, they could develop efficient transportation systems. They could also review the effect of urban development on traffic systems. And also, they could simulate traffic in an intersection to make sure that the traffic movement is smooth.
Historical development of transportation. Before every other form of transportation, humans travel on foot. Can you imagine walking from Batangas to Quezon City? According to the history, the first known transportation was walking. Humans began walking upright 2 million years ago with the emergence of Homo erectus. Fortunately, human beings learned to use animals. They use animals such as donkeys, horses, and camels for transportation from 4000 BC to 3000 BC. In 3500 BC, the wheel was invented in Iraq and the first wheel was made from wood. Initially, a canal-like structure was used for water transportation, which was built by burning logs and digging out of the burned wood. When was the sailing boat invented? The first papyrus sailing boats are estimated to have been made around 4000 BC. The Egyptians developed many types of sailing boats. Some were specialized for fishing and traveling, while others were designed for carrying cargo or going to war. They say that Romans had a significant need for good roads to extend and maintain their empire and develop Roman roads. Anyway, who was designed the first modern highways? In the Industrial Revolution, John Loudon Macadam designed the first modern highways using an expensive paving material of soil and stone aggregate macadam, and the embanked roads a few feet higher than the surrounding terrain to cause water to drain away from the surface. In 17th and 18th century, many new modes of transportation were invented such as bicycles, trains, motor cars, trucks, airplanes, and trams. In 1906, the first car was developed with an internal combustion engine. Many types of transportation systems such as boats, trains, airplanes, and automobiles were based on the internal combustion engine. The three leading automobile companies in the US in the 1920s were General Motors, Chrysler, and Ford. Furthermore, several styles of automobiles were produced such as two-doors, small, large, sports cars, and luxury cars. Presently, the latest car models have integrated improved in standardization, computer-aided systems, and platform sharing. The modern railroad system uses remote control for traffic lights and movement of traffic capable of speeds of more than 570 km per hour.
Good day, this is a transportation group, and today we're going to talk about the importance in the civil engineering field of this module. But it would be better if we would ask someone in the field with at least 42 years of experience.
Hi, good afternoon. This is Engineer Marvin Dutera. Let's talk about the important factors that we have to consider on the transportation industry. Because providing a good and proper roads, bridges will give importance on the mobility and the time factor from site to site projects. Mobility because it gives the professionals or the engineers to reach their destination at very soonest time, and at the same time giving them a proper time to finish the project the easiest or the fastest because of mobility.
I think it's not just being knowledgeable in vertical structures but also in the horizontal ones, not just buildings, structures, but also on the roads. Civil engineers has to be also proficient in understanding the road works, and also it's possible its traffic flow, the structure of networks the transportation needs to have.
Duties of transportation engineer: prepare project budgets, schedule, or specification for labor or materials. Supervise the maintenance or repair of transportation system or system components. Participate in contract bidding, negotiation, or administration. Evaluates construction project materials for compliance with environmental standard. Investigate traffic problems and recommend methods for traffic flows or safety. Analyze environmental impact for transportation project. Review the development plans to determine the potential traffic impact. Thus, evaluate the traffic control devices or lighting system to determine the need for modification or expansion. Prepare administrative, technical, or statistical report on traffic operation matters such as accidents, safety measure, or pedestrian volume. Develop or assist in the development of transportation related to computer software or computer processes. Plan alteration or modification of existing transportation structure to improve safety. Model transportation scenario to evaluate the impact of activities such as new development or to identify the possible solution to transportation problems. check construction plan, design calculation, cost estimation for completeness or accuracy to engineering standards or practices. Design or prepare plan for new transportation system or parts of system such as airports, commuters, train, highway, streets, and bridges.
Civil engineers helps the society by creating infrastructures that are necessary for the modern civilization. As being one of the main branches of civil engineering, transportation engineering helps the society to function and with its further development by providing an efficient way of transporting goods and its people. Transportation engineers are responsible for the planning and designing of infrastructures that are related to transport networks, as well as the supervision of its construction and its maintenance, such as roads, bridges, mass transits and railways, airports, ports, and harbors. The objective of their work is to have an optimized traffic flow and improve mobility, and also considering the safety, economic efficiency, and minimizing the harmful emissions of a transport network. During the planning phase, engineers ensure the safety and efficient travel of a vehicle from point A to point B by identifying the best route and possible problems that may occur on the other phases of the project, and also during the service of the infrastructure. During the design, not only the main infrastructure are to be considered. Transportation engineers also analyze and evaluate traffic signals. Traffic signs, as well as the condition of the environment where the infrastructure are to be constructed. Transport engineers work in offices and are also required to undertake site visits and community consultation. They may also be required to travel interstate or overseas for work. They may need to base themselves in the location of a major engineering site for the duration of the entire project. Transport infrastructures are very essential for the mobility of people and the transport of goods, so maintenance works are needed for the continuous functionality of such structures. If the necessary maintenance measures are not carried out in time, this can lead to traffic restrictions on individual routes or even to the failure of infrastructure elements, such as bridges.
Meet the famous Øresund Bridge in Copenhagen, Denmark. It is well known for its one-of-a-kind engineering feats of civil engineering. It is a combined railway and motorway bridge across the Øresund Strait between Copenhagen, Denmark and Malmö, Sweden. This bridge is the longest combined road and rail bridge in Europe, running nearly 8 kilometers or 5 miles from the Swedish coast to the artificial island, or man-made island known as Pebberholm that sits in the middle of the strait. The crossing is completed by the 4-kilometer or 2.5 miles Drogent Tunnel from Pebberholm to the Danish island of Amager. The average crossing time of a car to the bridge itself can reach 10 minutes. Many have asked, is it legal to walk across this bridge? Unlike the famous Golden Gate Bridge in San Francisco, USA, it is illegal to walk across this bridge and even through the tunnel itself. Many have attempted to walk through it, but delivering themselves straight to jail. In accordance to this, Danish police have arrested 4 individuals who are attempting to cross the Øresund by foot. Why did Denmark and Sweden agree to this massive project? What gave them motivation? The primary motivations for construction of the bridge is to improve transport links in Northern Europe from Hamburg to Oslo, connecting the 2 largest cities of the region, which were both experiencing economic difficulties, and also improving communications to Kastrup Airport, the main flight transport hub in the region. The construction started at the year 1995 and ended at the year 1999, followed by its opening to public on July 1st of 2000s. Øresund's design is known as the cable-stayed bridge that is supported by 4 pylons, giving its distinctive look of a handheld fan. The Øresund Bridge is one of the most complex feats of engineering, and some name it as the Impossible Bridge Tunnel.
One of the most famous transportation projects in railways is the Shinkansen. The Shinkansen is also known as the bullet train, and it is a network of high-speed railway lines in Japan. Initially, it was built to connect distant Japanese regions with Tokyo, the capital, to aid economic growth and development. Beyond long-distance travel, some sections around the largest metropolitan areas are used as a commuter rail network. It is operated by 5 Japan Railways group of companies. Over the Shinkansen's 50-plus year history, carrying over 10 billion passengers, there has never been a single passenger fatality or injury on board due to derailments or collisions. Starting with the Tokaido Shinkansen, which was 515.4 kilometers back in 1964, the network has expanded to currently consist of 2,764.6 kilometers of lines with maximum speeds of 240 to 320 kilometers per hour, 283.5 kilometers of mini Shinkansen lines with a maximum speed of 130 kilometers per hour, and 10.3 kilometers of spur lines with Shinkansen services. The network presently links most major cities on the islands of Honshu and Kyushu and Hakodate on northern island of Hokkaido, with an extension to Sapporo under construction and scheduled to commence in March 2031. The maximum operating speed is 320 kilometers per hour on a 387.5 kilometer section of the Tohoku Shinkansen, and test runs have reached 443 kilometers per hour for conventional rail in 1996 and up to a world record of 603 kilometers per hour for SC maglev trains in April 2015. The original Tokaido Shinkansen connecting Tokyo, Nagoya, and Osaka, 3 of Japan's largest cities, is one of the world's busiest high-speed rail lines. In the 1-year period preceding March 2017, it carried 159 million passengers, and since its opening more than 5 decades ago, it has transported more than 5.6 billion total passengers. At peak times, the line carries up to 16 trains per hour in each direction with 16 cars each, with a minimum headway of 3 minutes between trains. Japan's Shinkansen network had the highest annual passenger ridership of any high-speed rail network until 2011, when the Chinese high-speed railway network surpassed it at 370 million passengers annually. reaching over 2.3 billion annual passengers in 2019.
Contribution of transportation engineering. Transportation engineering contributes mostly in mobility of traffic. Here are some factors transportation engineering mostly contributes to. Number one is traffic engineering, a branch of civil engineering that uses engineering techniques to achieve the safe and efficient movement of people and goods. It focuses mainly on research and constructions of the immobile infrastructures necessary for this movement, such as roads, railway tracks, bridges, traffic signs, and traffic lights. Increasingly, however, instead of building additional infrastructures, dynamic elements are also introduced into road traffic management. Next is urban planning, is the forward-thinking process whereby towns, cities, and urban areas are laid out based on a set of objectives designed by the state or territory in conjunction with local councils. Urban planning affects our transportation systems, infrastructures, the layout, and the prescribed densities of our residential, commercial, and industrial areas and more. Without such planning, our cities quickly become inefficient and uninviting for residents and businesses alike. Last is transportation safety. Performances is linked to a variety of elements, including roadway design, traffic law enforcement, road user behavior, and emergency response time. Therefore, effective transportation safety warrants a multidisciplinary approach. Engineers play a critical role in identifying and recommending solutions to address safety performances of the transportation infrastructures. Some of their responsibilities may include managing and participating in the development and implementation of a statewide or regional road safety plan, collecting and managing crash data, analyzing crash data to identify safety issues and projects, utilizing analysis method such as network screening and sharing the results, identifying safety projects and countermeasures, designing improvements, conducting before and after studies, managing roadway improvements, and coordinating safety issues with other statewide, regional, and local engineers. Thank you.
Hi, my name is Jeffrey Solivillo and I will be discussing an example of newer trends and innovations in the field of civil engineering. And one of those is drones or UAVs, also known as unmanned aerial vehicles. So let's start. Drones are set to become increasingly common on construction projects throughout 2020, from undertaking inspections, ensuring that operatives are kept out of harm's way, to surveying vast areas of lands in just a few minutes. The continued rise of UAVs will considerably improve safety and productivity in construction. Drones are the foremost widely used emerging construction technology. They can conduct site surveys more quickly and accurately than a crew on a bottom that are cheaper than aerial imaging. Their high resolution cameras are therefore the data collected can create an interactive 3D or topographical maps and models and take volume measurements. Another advantage of using drones is that the ability to examine hard to succeed in places like bridges or around tall buildings and to try to do it safely. You can also use them to watch the progress on the employment site and see how people are working. Many construction sites are already heavily hooked on the utilization of drones. These drones are very beneficial in that they save a lot of time. For instance, surveyors can survey an entire site in just a few minutes, whereas it takes several weeks or months in the past. This will also save construction companies tons of cash. As drone technology continues rapidly developing in the accuracy and precision of its readings, even less human involvement is going to be necessary. So that's an example of new innovations and trends in civil engineering field.
Good day everyone. I'm here to report latest trends in transportation engineering. In this PowerPoint presentation, I'm going to show you 5 latest trends in transportation engineering, which are integrated frictionless travel, digital identity, innovation accelerators, customer experience, and last, AI augmented mobility. First is integrated frictionless travel. Transportation planners see a growing need to make travel more seamless with minimal stoppages and checkpoints. This trend is manifesting in many ways, including mobility hubs that enable multimodal transportation, the rise of mobility as a service, platforms for ticketless travel and innovation in micromobility, and last mile connections. Digital identity. Transit and transport agencies across the country are using digital technology to increase throughput, improve security, and help drive a better experience for users. This trend includes a move toward digital driver's licenses to enhance security and experimentation with biometric and facial recognition to improve efficiency and throughput at airports. Third is innovation accelerators. Transportation agencies are tapping into private sectors expertise and building public-private coalitions to drive innovations in multimodal transportation, autonomous and connected vehicle technologies, mileage-based pricing programs, and much more. Next is customer experience. Transportation agencies and the broader mobility ecosystem are placing more emphasis on customer experience, putting the user's needs front and center, making it easier to use digital transportations tool. They're also simplifying in-person transaction at the local departments of motor vehicles, providing better infrastructures for pedestrians and offering more inclusive travel options in urban areas. And last, AI augmented mobility, a transportation ecosystem enabled with artificial intelligence or AI can harness the power of data analytics and cloud to help reduce travel time, manage congestions, improve regulatory compliance, support air traffic control, enable dynamic policy making, and deliver many other benefits. In this report, we examine these trends and how they are reshaping aspects of how people and goods move across the U.S. transportation networks, both on the ground and in the air. It is designed to assist public transportation leaders who see the necessity for change and are looking for innovatives idea to show that the best way forward are understanding these trends is a first step in navigating today fast changing mobility landscape.
For this topic, the trends and discoveries, so we live in an increasingly digital world and transportation industry is naturally impacted by this in a big way. Transportation companies can redesign services and products starting with improvements to vehicle design of road, rail, and sea. This can extend to the cargo-related vehicles. Meanwhile, digitalization continues to encourage further improvements to journey, reducing the need for investments time, effort, and money. Digitalization doesn't only improve the consumers, it also increases the speed of productivity during aspect of manufacturing, what do you call this, loading, fulfillment, and payment processing. While digitalization is nothing new, the improvements in software and hardware, including smart technologies, are set to take efficiency to a greater level than ever before. For big data reliance, including the ability to analyze and systematically extract information, is a big part of the transportation industry. The automated data gained through this process pinpoint clear trends related to key aspect of their operation. In turn, this allows managers and decision makers to act with confidence and accuracy, particularly through machine learnings. This can relate to anything from costing to logistics, supplier choice to manufacturing process. Transport planners utilizing big data in more prominent fashion will be positioned to make better decisions for themselves, business, and the end user, regardless of which sector of the industry they are situated. The data collected from the road users, consumers, and the other can be used to great effect, thus reducing inaccuracies and supporting sustained success. Location intelligence. To my research, location intelligence is technology that is growing in popularity across a host of industries. However, the transportation industries are perhaps the greatest beneficiary from a logistics perspective. The use of anonymous mobile location data collects pings from mobile devices and can be used for one-to-one interactions, creating a better user experience for road user while also spotting trends such as which modes of transport are used for roads. Whether working as the transportation planner for road planning or working directly within the transportation services industry, location intelligence can also use flexible static periods to identify changes between weekdays and weekends. An immersive open source of user interface and rich application programming interface are used to provide transport industry professionals with greater insight and improved capabilities. So for the last one, I get from the source, reduce traffic. So road planners and managers would love to take all the credit. While smart city design are an important feature, the fact is that modern communication enables a lot of people to work from home. As of now, I think it reduces the volume of vehicles on the road, which is crucial counterweight to the rapid population. Can have a positive impact for some and cause problems for others depending on the sector they're in. A lot of individuals that work remotely no longer need their own transportation or the use of public transport. Of course, those selling vehicles or manufacturing anything related to transportation will face new challenges as a result. However, transportation services can complete segments a little quicker. On a side note, pollution and vehicle performance can be affected by this issue.